Okay, welcome. This is section 3.3, and now we're going to start talking about systems of linear inequalities as opposed to systems of equations and how to solve those. Now, the good news is there's only one method that really makes sense for solving inequalities. The bad news is if you're not a big fan of graphing, you may not be pleased with what's going to happen next. So let's just talk a little bit about what it means to solve a system of inequalities. Just like when we solved equations, we said that it was the point that both lines had in common. Well, now an inequality is the same thing. It's the points that satisfy all of the inequalities in our system. However, just like when we graphed one inequality in the last chapter and we shaded a region and we had a lot of different points, the same thing is going to happen here with a system of inequalities. It's generally going to be an infinite set of points, a shaded region. So the best way to solve it is through graphing, not through some of the algebraic methods that we talked about earlier when we were dealing with linear equations. So you're not going to really use substitution or elimination here, unfortunately. All right, so here's how we would do it. We graph each of our boundaries separately, either dotted or solid, depending on whether or not there is an equal bar in the inequality. And then we'll graph each of our inequalities to shade them. The solution, as you see in step 3, that's the region that is shaded for all of the inequalities. So it's the shaded regions that are shared by all the inequalities. Okay, let's look at one example. So we've got y is less than negative 1/2 x minus 6, and y is greater than x plus 3. So we'll do each of these separately, but on the same grid. So I'll start with the first one. I'll do it in red. So y is less than or equal to negative 1/2 x minus 6. So I'll start at negative 6, and I'll go down 1 over 2, down 1 over 2, so on and so forth. And I'll connect my dots, and I will make a line, or an attempt at a straight line. Stop. Okay, something like that. Now, it's less than in this first inequality. So as we remember from earlier, less than usually means we shade underneath the line. So that's what I'm going to do. But instead of shading, and this is just a strategy for these, I'm going to use arrows to kind of say this is where I would shade. You'll see what I mean in a second why. I do it just to keep myself organized, keep myself focused, and I don't get anything messed up. Now I'll do the next one. Y is greater than x plus 3. So I'll start at 3, and then I'll go up 1 over 1, up 1 over 1, and these are all my different points that I'll connect to make my straight line. And this is strictly greater than, so I'm not going to use a solid line anymore, but I'm going to use a dotted line going all the way up. My apologies for this not being straight. It's just the technology that I'm working with has some limitations. So I'm going greater than, so I want to shade above this line. Now, you'll see where my arrows come into play here. The reason why I'm using the arrows is I'm going to shade the region where both of my boundary lines are pointing. And if you look right here, the dotted line is pointing and the solid line is pointing. So it is in this region that both inequalities are true. All right, so it's a little bit different, but basically just like how we graph two lines and we look for the intersection point earlier in chapter 3, well, now we're going to graph two inequalities and look at the intersecting region. Let's try another one. Y is greater than or equal to 11/7 x minus 3. So I'll start at negative 3. Okay. All right, I'll go up 11 boxes. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and go over 7. Okay, and I will connect my points with a straight line. Y is greater than, so I will shade above, or rather I will put my arrows above this boundary. Okay, Now I'll do the same thing with the second inequality, less than 3/7 x plus 5. So I'll start at 5, go up 3, and over 7. And this one is also going to be a dotted line because there's no bar. And there we go. Less than means we shade below the dotted line. And you could use the test points for all of these, but I think to save time, we're at the point now where I think we can use our shortcut, less than below, greater than above. Now, if you look, this sort of triangular region right here, I've got the dotted line pointing down and the solid line pointing up, so it is within this region that I would shade. And if you ever wanted to check your solution set to make sure it was true, you would just pick something inside this dotted or inside this shaded region, plug it in, and see if both inequalities are true. Not too bad. All right, now let's look at what happens when one or both equations are not in slope-intercept form. So I could be a meanie and give you something like this. 4x plus 5y is greater than or equal to 15, and then 3x plus y is greater than negative 8. So I've got to put both of them in slope-intercept form before I even graph. So I'll start with the first one. Got 5y is greater than or equal to negative 4x plus 15. And then I'll divide through by 5, and I get y is greater than or equal to negative 4/5 x plus 3. So let's graph that. We'll start at positive 3 on the y-axis. I'll go down 4 and over 5 and put a second point. If I have enough room, I could go down 4 boxes and put a third point. And then I will connect these with a solid line like so. I'm doing y is greater than, so I'm going to shade above. So I'll put my arrows pointing above the boundary line. And now I'll come up with my second boundary line. So for 3x plus y is greater than negative 8, all I've got to do is move my 3x over, and I get negative 3x minus 8. So I'll start at my minus 8 on the y-axis. I don't have enough room to go down 3 and stay on the grid, so I'll go up 3 and over to the left 1 instead. Up 3, over to the left 1. Okay, and I will connect those dots with a dotted line. Okay, it's greater than, so again I'm shading above the dotted black line. Now I'm looking, where are my red arrows and where are my black arrows pointing in the same spot? They are pointing, let me use a completely different color for you to see it, here, and then it kind of curves off and hugs the red line. So in this yellow region, any point would make both inequalities true. These are all solutions to my system of inequalities. Okay? I think I've given you enough practice or enough example problems to try. You've got a few more in your notes. Give the ones that I ask you to do for practice a try now. We'll look at them in class. If you have any questions, be sure to bring them to class. I'll show you how to do all this on your calculator. I'll show you a couple other tidbits related to this when we meet again. So with that, have a great evening.